for lesson 5, solving rational equations. And our essential question is, how can you solve rational equations and identify extraneous solutions? Here's our table of contents. Solve a rational equation. What is the solution to the rational equation 1 over x plus 4 equals 2? So a rational equation is an equation that contains a rational expression. So it is essentially a number or an equation that contains a fraction. If there is a whole number on one side, change it to a fraction. So all we're going to do is change that 2, so it has a 1 in the denominator. Okay, we're not actually changing the value of anything, but we're changing it into a fraction. We're going to cross multiply. Okay, so we're going to multiply 1 times 1, and then the x plus 4 times 2. Okay. That is going to give us this, and then we're going to simplify it. Okay. So that gives us 2x plus 8 equals 1. So again, 1 times 1 gave us that 1. The 2 times the x plus 4, we distributed that 2, so we got 2x plus 8. We're going to subtract 8 from both sides, which gives us 2x equals -7, and then divide both sides by 2, which is going to give us x equals -7/2. So if I substituted x equals -7/2 into my left-hand side of my equation, I would get that it equals 2 when I simplify it. Okay, 1 over x minus 3 equals 5. Okay, so again, there's a whole number. We're going to change it to a fraction. So 5 over 1. We're going to cross multiply and simplify. So 1 times 1, and then 5 times x minus 3. We're going to distribute that 5. Okay, so that gives us 1 equals 5x minus 15. We're then going to add 15 to both sides and simplify, which gives us 16 equals 5x. And then, of course, divide by 5 to get x by itself. Okay, so that gives us an answer of x equals 16/5. Solve a work rate problem. Gabriella and Anthony can paint a wall in 6 hours when working together. Gabriella works twice as fast as Anthony. How long would it take Gabriella to paint the wall if she were working alone? So I wanted to determine the work rates of both Gabriella and Anthony. So I'm going to let X represent the number of hours Anthony needs to paint the wall himself. Anthony can paint one wall in X hours, or 1 over X of a wall in 1 hour. Gabriella can work twice as fast, so Gabriella paints 2 over X of a wall in 1 hour. Okay, and together they paint one wall in 6 hours, or 1/6 of a wall in 1 hour. Then I'm going to write the equation for their rates working together. So if Gabriella and Anthony work together, they're going to paint the wall in 6 hours. So 1 over X plus 2 over X equals 1/6. So again, this is the working rate for Anthony, that 1 over X. The 2 over X is the working rate for Gabriella. Okay, they are like fractions, so I can just add them together. So 1 plus 2 gives me 3, so I have 3 over X equals 1/6. Then I'm going to cross multiply, so 6 times 3, X times 1. Okay, that gives me 18 equals X. So what that tells me is that it takes Anthony 18 hours to paint the wall alone. Since Gabriella works twice as fast as Anthony, it would take her 18 divided by 2, okay, or 9 hours to paint the wall alone. Identify an extraneous solution. Identifying an extraneous solution. So an extraneous solution is a solution that makes the value of a denominator in the original equation equal to 0. Okay, so I want to know what the solution of the equation 1 over x minus 5 plus x over x minus 3 equals 2 over x squared minus 8x plus 15. Okay, so the first thing I want to do is I actually want to multiply each side of the equation by its common denominator. So if I break down x squared minus 8x plus 15, two numbers that multiply to get me 15 would be 5 and 3, and they would add to get me 8 as well. So x squared minus 8x plus 15 is x minus 5 times x minus 3, so we factored that. So I'm multiplying both sides of my equation by x minus 5 times x minus 3. Okay. So I'm taking this x minus 5 and I'm multiplying it by each of my numerators and my fractions. So I get 1 times x minus 5 times x minus 3 over x minus 5 plus x times x minus 5 times x minus 3 over x minus 3 equals 2 times x minus 5 times x minus 3 over x squared minus 8x plus 15. Okay. From there, I can divide out the common factors in the numerator and the denominator. So basically what I'm doing is I'm getting rid of the fractions. I'm creating an actual equation, which is something we're very familiar with. Okay. So my first fraction had that x minus 5 in the numerator and denominator. My second fraction has an x minus 3 in my numerator and denominator. And of course, my third fraction has both an x minus 5 and an x minus 3, which gets rid of the x squared minus 8x plus 15. From here, I can solve the equation. So I get x minus 3 plus x times x minus 5 equals 2. I'm going to go ahead and distribute that x. So I get x minus 3 plus x squared minus 5x equals 2. I'm going to rearrange the left side of my equation over here so it's in descending order. Okay. So I get x squared minus 4x minus 3 equals 2. I'm going to subtract that 2 to the other side. Okay, that gives me x squared minus 4x minus 5 equals 0. Now I'm going to factor that. So I'm asking myself what two numbers multiply to get me -5, but add to get me -4. So again, I've got 5, right? I know that 1 times 5 gives me 5, but one of these has to be negative because it's either -1 times 5 would give me a -5, or 1 times -5 would get me a -5. Okay. And I also need to have a -4 here when I add them together. So 1 plus that -5 is what's going to give me that -4. Okay. So those are my two factors, 1 and -5. Okay. So that gives me x minus 5 times x plus 1. It doesn't matter which order you do them in because of multiplication. It doesn't matter the order. Okay. So that means x equals 5 and x equals -1. Okay. But if I go back to my original equation, right, x minus 5, x minus 3, okay, I've got x equals 5 as one of my solutions. But if I put 5 in here for my first equation, 5 minus 5 is 0. That means it's an extraneous solution because I can't divide by 0. Okay. So the only solution that I would have would be x equals -1. So when you're solving for rational expressions, you always want to double check and make sure that it doesn't have an extraneous solution. So you want to substitute your solutions back into the original equation. If they make the denominator equal to 0, that means it's an extraneous solution, so it's not actually a solution for the problem. Okay. You can also confirm with a graph. So if I were to graph 1 over x minus 5 plus x over x minus 3, and then 2 over x squared minus 8x plus 15. Okay, we'll get a graph that looks like this. Okay, so we can see that x equals 3 and x equals 5. They're both vertical asymptotes for both of my equations. Okay, so therefore neither graph has a value at x equals 5 since that is one of my vertical asymptotes. The graph only intersects in one point, and that's at x equals -1. Solve problems with extraneous solutions. What is the solution to the following equation? 5x over x minus 2 equals 7 plus 10 over x minus 2. So again, I'm going to multiply both sides of my equation by a common denominator, in this case, x minus 2. When I do that, I can cancel out my common factors, which is the x minus 2 for both my fractions. So I'm left with 5x equals 7 times x minus 2 plus 10. I'm going to distribute that 7. So that gives me 5x equals 7x minus 14 plus 10. Okay. And then I'm going to start combining my like terms. So 5x equals 7x minus 4. Okay, so again, that was from that negative 14 plus 10 gave us that negative 4. Okay. I'm going to move the 5x to the other side. So that gives me 2x minus 4. And then I'm going to move the 4 to the left side of my equation. Okay, so that gives me 4 equals 2x. Now I'm going to divide both sides by 2 because I want to get x by itself. So that gives me x equals 2. I'm going to then substitute that value back into my original equation. If I look at my first fraction, 5x over x minus 2, if I substitute 2 in there, I get 0 in my denominator. That means that this is an extraneous solution. So that means that this equation has no solutions. There's not a solution that will work that will give me the same equation on both sides, equal on both sides. Okay. What is the solution to the following equation? 3 over x minus 3 equals x over x minus 3 minus x over 4. Again, I'm going to multiply both sides of my equation by a common denominator. In this case, 4 times x minus 3. Okay. I'm going to cancel out my like terms in my numerators and my denominators. So that gives me 4 times 3 on my left side, and then 4x minus x minus 3 times x on my right side. I'm going to go ahead and distribute and simplify. Okay, so 4x minus x squared plus 3x. So again, I simplified that. So I get 12 equals negative x squared plus 7x. I'm going to move everything to one side of my equation. And I want my x squared to be positive, so I'm going to move it to my left side of my equation. So that gives me x squared minus 7x plus 12 equals 0. I'm going to factor. Again, I'm looking for something that multiplies to get me 12. Right? So I've got 1 and 12 as a possibility, 2 and 6 as a possibility, 3 and 4 as a possibility. Okay. 1 plus 12 would give me 13. 2 plus 6 would give me 8, but 3 plus 4 would give me 7. It's a negative 7, so that means both of my numbers would have to be negative. Okay. So when I factor, I get x minus 4 times x minus 3. So that means I have two potential solutions, x equals 3 and x equals 4. If I substitute those values back in, x equals 3 would give me a 0 in the denominator, so that means it's an extraneous solution. So the only solution to this problem would be x equals 4. Solve a rate problem. Paddling with the current in a river, Susie traveled 16 miles, even though she paddled upstream for an hour longer than the amount of time she paddled downstream. Susie could only travel 6 miles against the current in still water. Susie paddles at a rate of 5 miles per hour. What is the speed of the current of the river? Okay. So we know that distance equals rate times time. So time equals distance divided by rate. So the distance she paddled upstream or downstream, in this case, is 16 miles at a rate of 5 plus c, right? 5 plus the current. Okay. And then downstream, she traveled 6 miles. Okay. And that's 5 minus c. So 5 miles against the current. So the current of the water is going to be 16 over 5 plus c plus 1, right? Because you traveled an hour longer upstream. She traveled an hour longer. Okay. Equals 6 over 5 minus c. Okay. I want to find the LCM. In this case, 5 plus c, 5 minus c. Okay. And then I want to multiply both sides of my equation by my least common multiple or my least common denominator. I can cancel out the ones that are the same and simplify. When I do that, I get 80 minus 16c plus 25 minus c squared equals 30 plus 6c. I'm going to move everything to the other side of my equation and simplify. So I get c squared plus 22c minus 75. Here I'm looking for two numbers that multiply to get me 75, but add to get me 22. Well, 3 times 25 would get me 75, and 25 minus 3 would get me 22. So that means 3 has to be negative, 25 has to be positive. Okay. This means that there are two solutions or two potential solutions. So C equals negative 25 and C equals 3. We know that the current can't be negative, so that means that C equals negative 25 is an extraneous solution. This means that our answer is C equals 3 or 3 miles per hour. Okay. Summary. So a rational equation, again, is an equation that contains a rational expression. To solve, we identify the domain for the variable, then multiply both sides of the equation by a common denominator and solve. An extraneous solution is a solution to the equation that is not valid because the value is excluded from the domain of the original expression. And here are two examples of solving for rational expressions. 1 over x plus 2 over x equals 1/6. So again, I'm multiplying by 6x and simplifying, so I get x equals 18. Good. And then the second, x squared plus 4 over x minus 1 equals 5 over x minus 1. When I simplify it, I get x could equal positive 1 or negative 1. But if I put positive 1 back into my original equation, I find that it's an extraneous solution. So my only solution to this equation is going to be negative 1. And that is the end of Unit 4, Lesson 5.